All right, it is Advent of Code, day 23. Yeah, here we go. Okay, some kind of grid. Next step must be downhill. Never step on the same tile twice. What is the longest hike you can take? Okay, it's like a longest path problem. How many steps is the longest hike? You can only go downhill. Okay. So this is just going to be how do we do this? Do we just want to DFS? BFS? How many like branch points are there in here? I guess quite a few. Well, anyways, let's write this. And then what we'll do is, so if you step onto a slope tile, must be in the direction the arrow is pointing. Okay. If the slope tiles are one of these, then there's only one adjacency, and okay, so this direction is -0 or -1, 0. This, which means this direction is 1, 0. This is 0, 1, and this is 0, -1. So we index that by g cx cy. And then what we do is for dx dy, and then just if I think this. Okay, so that gives us the adjacencies. And what we do now, I'm trying to think if we BFS, is this just clearly bad? So any of these like dead ends can probably be eliminated, I think. Do we need to do that? I guess the DFS should just like return quickly from them. Let's just write it. Problem with the DFS is I can't really tell how far it's going. I will write the DFS. So we'll do cur and then path. And the question is, just longest hike you can take. You don't need to end anywhere. Do you have to end at the bottom left? Oh yeah, no, you do have to reach that one. So the start location is so here's what we'll do. Path should be, I'm making both of these just for efficiency. Then I think just this, right? And then at every call, we'll do if cur is equal to, what's that location? It's going to be n, and then n minus 1, and minus 2. And I guess I can, for starters, I'll just print best, see if that ever terminates. And then we start at, I think, 0, 0,1 with empty path and empty set. So for starters, we do that. Oh, what was best? 2178. Is that accurate? Oh yeah, that's the answer. Okay, rank 16. That was way faster than I thought. Treat all slopes as if they're normal paths. Oh, yeah, this is going to make it not terminate, I think, right? Yeah. Oh yeah, it restarted. Why? You still can't step on the same path. We're like hitting max recursion depth? That seems weird. Felt like we should not. How many tiles are there? Oops. Okay, that is a lot. So I think now this is like a general longest path problem, and this makes it a lot harder. I'm not sure. Let me see if anyone solved it yet. Nobody solved it yet. Maybe I just want to use some generic Python like longest path finder. I actually don't know the algorithm for longest. Longest path is an NP hard problem in general. I don't know the algorithm for longest path off of the top of my head. But I think we can do is we can like look at all split points where the path like diverges, and then but we can't even walk back onto that point. So you still can't step on the same tile twice. Does it make sense to do search from both ends? I don't really think so. But it is true that these can all be compressed into like one node. Is it just the case that like this has some really special structure? It probably does, right? Whenever we see like a split, like is it always one wide? If we started this at the beginning, where do we end up like seeing our first split? I'm just like tracing this path with my eyes. Here's a split here. So I think it's the case that once we split here, like even if we go this way, it doesn't matter because we can't get back to the we can't ever like go through this. So I kind of want to flood fill this and like just look at the structure of this. Is it just one giant tree? There's no way it's a tree, right? No, if it was a tree, then the answer would just be the same, basically. How about I check easily if it's a tree? I could do let's check if it's a tree real quickly. I kind of doubt it is because this would be like trivial, I think. But we'll count the number of edges. That's awfully close, but it's definitely not. So it is cyclic. Python. I'm just wondering if there's like a solver that I can use. That doesn't help. Just use a DFS. Maybe I just do the path compression thing. Okay, so someone solved it. I think the DFS should just work. It can't have that many splits. It's probably just a matter of this is like inefficient because of the like all the recursion that happens unnecessarily. So let's do make a graph. And what we'll do is if the number of adjacencies on any tile is larger than 2, or larger than 1, larger than 2. 2 is like connected in 2 directions. 1 is a dead end. So larger than 2 would be like a split point. Then we'll call this a vertex. And otherwise, what are we going to do? How am I going to like actually connect these up? I guess I could just DFS out from each one and stop when I hit another V, or like BFS I meant. And that should give me the paths from each. Okay, but for starters, let's do this. Let's also add 0, 1, and let's add n-1, n-2. These are destinations. What? Hello? I and J, G, I, G, I, G, J. Oh, right, it's because I do this. G is my grid. Okay, so these are all our split points, and like 2 to the 36 is a little unfeasible, but the DFS is probably just not all of that. What we'll do now is, can I really not get the distances in this way at all? Well, in any case, for no, let's just do this. For vertex in, or I'll just do x, y, and v. BFS out, so Q would be a deck. Q dot append x, y. And what we'll do so actually let's make Q this. For A and adjacencies of, good, I have that commented out, of for C and Q in every adjacency, in on scene. And then Q is NQ. And now what we do is for so I'll do one more thing, which is just, and if A is in the vertex set, then what we're going to do is we found our distance, so we know that there's an edge from x, y. There's an edge of weight dist, and it goes to this location. We could add it the other direction, but we don't need to. And otherwise we do this. So if we do see this, we stop there. We should add it to scene so that we don't redo this one. But that should just give us that. And I think this should, it's pretty slow. Oh, oops. Q equals NQ. Cool. I think I could just print this. Yeah, so nice. And this has a few edges. Cool, this looks good. And now we can just do the DFS, and hopefully it's efficient enough. I will note that this is the number of steps. We're gonna have to think about number of cells. I think it'll be just 1 plus this. But let's like rewrite the DFS. I think I could just copy this probably. I don't care. Actually, I do care about the path and the path set. And I also care about the total dist. And now what we'll do, get rid of that. If we're at the destination, yes. So by the way, let's do n-1, n-2. There should only be one thing, by the way, from 0, 1. And there should only be one thing from this location as well, probably. Yeah, okay, cool. That checks out, because these are like dead ends. Any other dead ends in the graph, we just ignore this approach. That's actually quite good. And now what we do is, for instead of this, it's going to be GD of cur, and it'll be like D dist and A. And if A is not the path set, meaning we haven't seen it, then I think we can just do this. We don't actually need the path. And when we're done, and then the new dist is total dist plus DA, and max of total dist and DFS at 0, 1, set 0, and I'll note that it should be the answer. It should be this plus like we have an upper bound here of like 9,000 or something. I mean, I can just like, it should take more than a minute, so I could just submit this, I think. Not the right answer. That's fine. Still chugging along. Okay. Oh, and there's our answer. Wow, okay, well, I actually do kind of regret submitting now, because this should be correct. At least I hope it's correct. It's a few solves in. Let me make sure that it's plus 1. So if we had, I'm just thinking about the small case, then this would be 2, and the actual number of cells is 3. If we're adding like 2 and then another 2, it's still going to be 2 plus 2 plus, that's 4 plus 1, that's 5 cells. So yeah, it should be that plus 1. It should in fact be this number I have here. 12 seconds. I sure hope it is. 5, 4, 3, 2, 1. Not the right answer. Okay. Shoot. I guess I could try this. And my code should be generic. 155. Oh, it's the number of steps? Ugh. So it actually is not plus 1. Ugh, that's dumb. Wait, in part 1, wasn't it? Oh, it was steps. Huh, did I accidentally have an off by 1 or something? length of the path. Kind of wondering why I got the right answer in the first part, but I'll not worry about that. In any case, then this is the answer probably, and 4 seconds. I really hope it is. If I have a bug. Ring 15, okay. Oh, man, that was, okay. Well, I don't think I actually lost a whole lot of time, a whole lot of ranks to that. Yeah, I guess I would have been 14th instead of 15th had I not had that off by 1. Or I guess I had, and then I also submitted early, which also cost me like maybe 30 seconds. So even like a minute and 30 seconds down, I would have only been 13th. So that was actually like a very that was not a bad bug. Wait, I'm really confused why my part 1 worked. Because I thought that I was doing the length of the path. Oh, okay. So, wow, I got lucky. Yeah, I did sort of have a bug here. This was part 1, and I thought I wanted the total number of like grid cells on the path, which is why I was using the length of the path. It actually wanted the number of steps, which is always going to be the length of the path minus 1. But since here cur has not yet been it has been appended to the path, hasn't it? Yeah, now I'm confused. The sample input. Let me not print. 154. This is on the sample input? Where are my prints? Oh, right. And then we'll do if, I'm just making my code be able to handle part 1 and part 2. If part equals 1 and this, and let's do adjacencies. I'll set it to default to part 2. Okay, so 94. Why is this not off by 1ing? Oh, it doesn't start it with 0, 1. Oh, okay, yeah. So I did have like a sort of bug, but the bug happened to be exactly what the question was asking. So I was not appending 0, 1. Wow, I got so lucky, man. And this would have taken me like a solid second to like a minute at least to figure out. It obviously would have cost me a minute because I would have had a wrong answer. I guess a minute would have been not that bad, but then if I spent like another minute debugging, yeah, I would have been like significantly further down here. Yeah, I got quite lucky there. Man. Yeah, I was not appending 0, 1 to the path, so the length of the path was actually always 1 less than what it was supposed to be. But what I wanted was number of steps, not length of the path. Man. Okay, well, I guess I'll explain today real quick. What are these prints? I guess I'm doing this. Maybe I'll just get rid of this print. And just run this and verify. Yeah, so part 1 basically gives you this grid, and it says this is like a normal grid. You can like walk through these empty cells, and these are like walls. But when you enter one of these slopes, you are forced to go in that direction on your next step. So if you enter this V slope, you have to go down on the next step. In this case, you don't actually have much of a choice because you couldn't go back up anyways. Oh, there's also one more constraint. You can't backtrack. You can't go back to a cell you've already been to before. So in this case, it doesn't really matter because you couldn't even go back up there. But I guess there are probably other cases in this grid. I'm trying to look. Yeah, I guess like we could go through this way, and eventually, oh, whoops, I went the wrong way. But I think eventually you can get to here, And then, oh, here you can't go up either because otherwise you can't get back down again. In any case, these slopes should constrain the problem because they force you to go in a certain direction once you enter an area. And it basically just asks, what is the longest path? And the way I solved this was I just wrote a DFS, implemented adjacencies, and just DFS through every possible path. And this actually finished like quite quickly, mostly because of the constraining factor of these slopes. And that's like just the answer. It wants the length of the longest path. Part 2 now says, okay, remove these slopes, just pretend that they're normal paths. Now what's the answer? And it's not really a simple change like this. This was my code that was forcing the direction. And you can't really just remove this because now the problem is substantially harder and less constrained. So your DFS from before the path can be significantly longer. And yeah, that just doesn't work. It might have actually still worked had I not hit the stack limit. I'm wondering if it would or would not have, because I feel like people would have solved it faster if it just worked. But in any case, a thing that you can do is you can... never mind. I started to have the beginnings of the thought, but a thing you can do is realize that the paths here are all like one wide. So a lot of this graph information is like kind of meaningless. Like if you're just going to go down a hallway that you know is like 200 steps long, there's no real sense in doing a recursive call for each one of those. So what you can do instead is first you can compress the graph. So rather than having like one cell's adjacencies be the cells near it, you can only look at the intersections and make the adjacencies of the intersections the other intersections. And in this way, I kind of want to like do a diagram of this or like a visual thing. Maybe I'll do that after I finish explaining. But yeah, and sorry, I keep losing my train of thought. You can just connect the intersections and you can now make it like a weighted graph where the weight is the total number of steps between those intersections. And then you can do the same DFS approach from earlier, and you don't waste a bunch of recursive calls doing like nothing of interest. And this is the only optimization you need, and it just works. It is of course still slower than part 1, but it's not so slow as to not be feasible. So cool, yeah. I was trying to think if there's like a more efficient heuristic way to solve longest path than just like brute force DFS. I mean, obviously not actually more efficient because longest path is an NP hard problem. But when I was Googling it earlier, I was thinking maybe there's some heuristic-y like solver library I could use that's well optimized. But the DFS is just good enough once you do this like graph compression thing. But cool, yeah, that is all I have for day 23. I guess I can just do a little bit of messing around with the I like to produce some fun visuals. So what I can do, I don't think we need this. How fast is this now? What? Shell restart. Why? Oh, because I commented this out. Okay. It was because it was like Stack Overflow in the first one. Cool. And yeah, just for fun, let's do produce some nice visuals. Let's do n by m, 3 colors, and we'll do let's take a look at the graph, the grid, np dot uint. I do still want this process because I'm going to use that in a second. I cannot type. What? You're kidding. Does not support item assignment? Oh, wait, what? Oh, I wanted shape and D-type. Okay, that should hopefully work now. Show me. Lovely, and there's our grid, nice and anti-aliased. Let's do, I always rewrite one of these. I just like blowing up the image a little, so it's nice to do this. M of I, j. Surely that'll work, maybe. No. Huh, that did not in fact work. Oops, this should be factor times. And what I'd like to do, did I not close the other one out? I did not. Cool, and now I don't get like the weird anti-aliasing blobs. So I'd like to highlight the intersections and sort of just draw the edges in different colors. So let's do so we'll do for x, y, and v. I guess I can make it red. And what else I want to do is, yeah, so you can see these are the intersections. That's neat. And I care about the paths between them. Maybe I'll just make each one like a random color. I guess I need to use this step. Oh, I should have. Here, let me save as, do some visualization fun, and just to like preserve the old code, I will uncomment this and delete all of this. And surely that will work. Okay, and now I'm going to just throw the paths too. I'll keep like a parents dictionary. And for starters, this will map to nothing. And when we add something to the queue, the parent of A is C. And when we see this, so once we finish this, we know what GD of XY is defined. And what we can do, so I do want to look at, let's look at max of there we go. Okay, so the max distance between any two units is 474, or between any two vertices, and then the min is 21. So I guess I'll just like divide that by 2 and make it into a color. I am using maybe I'll make these more of like a orange, or no, I'll make them like purple. And then the paths between them. So now color paths between vertices. I'm not really doing this for any real reason. I just feel like making a visualization today. The paths between them will do, and I before people say this in the comments, I know that this is like a super hacky way of producing visualizations, and there are much better like tools for it. I just like using Python and NumPy and like converting into images and looking at them. I have produced videos this way before as well, by just like taking a bunch of frames and then slapping them together. Again, definitely not the way to like go about it, but it's just easy for me to do and kind of fun. So, cool. So the color we'll use. So let's do for some dist and some adjacency in GD of XY. So the color we'll pick will be like a pinkish thing. Actually, maybe we should make it some yellow too. Whatever. Dist lower 2. I'll just give it some green, and just so it's visible. And even when dist is small. And then what we'll do is we actually find the path. So path will start at just A. I think just like so. And for XY in path, M, XY. Oops, let's maybe not use this. It doesn't really matter, but still. Good practice. Will be the color. And send it. Let's take a look. No. I didn't redefine XY, did I? Nope. Okay. Well, that should be none, right? And oh, we never. Oh, okay, that's easy. Ooh, that didn't really look like what I thought it would look like, but and also we ended up overwriting the adjacencies, which I really did not mean to do. I thought that popping this would stop it from doing that. We popped the none. Oh, we also need a. It's hacky, but whatever. Okay, now it should. There we go. Oh, that's kind of neat. I maybe should just use like random colors instead. If I just use like a random color. So right now the colors are chosen where like I didn't actually think about what the colors would be, but I think a orange color is like a very long path, close to like the longest, and a deep green color is like a shorter path. So, but I guess sometimes it's a little hard to tell where the two paths are. So if I use random colors, maybe it'll be a little bit better. I guess I can use like a random pastel color or something. This is like roughly a random pastel color. Ooh, that looks pretty. Oh, look at that. Okay, wow, there's actually like more paths than you could tell by looking at this one. So that's pretty cool. Neat. I wonder if this is a good thumbnail for today. Maybe it's a little too colorful. Huh. Well, anyways, yeah, and this is just like a little neat to visualize, like you could see where the intersections are. And I guess this is much easier now to look at. So this path is forced, you take this one. But then maybe it's easy to tell now when you can like loop back. Yeah, there are probably some, I guess they're not really loops, but I guess I also didn't know that there were four-way intersections. I guess it's pretty reasonable that there are some. I just never saw any when I was trying to stare at the input really hard. There's like quite a few of them. Oh, and I guess I can also highlight the actual answer. So what I can do, it's gonna be a little annoying. This is gonna be so hacky. But if you need more state, just store the state, right? Who's to say you can't store as much state as you want? I'm just gonna store all my parents' dictionaries, and then what I'll do is keep track of the best path set. And here, that was bothering me a little. Cool. And then what we can do, so do I still show the image? Did I delete it? Oh, here it is. So we can produce two images. We can produce this one. And then also what we can do is we can produce the final image. Where what we'll do, so we have the best path set. This is annoying. Because I actually need the path. Anything for the sake of my visualization. Now we have the path, and now what we do is and we will look at the parents' dictionary of A. This is arbitrary, and then this is A. Nope, start at B. And then we do this. I think we don't need a pop for what I want to do now. And then what we'll do is, I guess I could just do this. Make it bright red. Let's make it a dark red. This isn't that dark, but darker red. And show that. Maybe that'll work. Okay, there's the pastel one. And of course, I cannot write, I forgot my path. Okay, there's our pastels. And this will take a little longer than it took before because now it's doing this. But these are both O1s, so it shouldn't be that big of a deal. Oh no, I guess the path copy is bad. But it shouldn't actually be updating this that often, the best path. So, what might be a neat animation is, oh no, best path of, oh come on now. That is definitely not. Wait, it has the right answer, right? And yet best path is none? That's clearly wrong. What? Path.copy. Path. Oh boy, what did I do wrong here? Wait, this seems like not... I'm not doing something obviously weird here, right? Oh, I didn't declare this global. Okay. I don't like these colors as much. These kind of blend. Oh well. Not much to do about it, other than restart. I mean, I obviously can just rerun it and get different colors if I want, but I want to see the path. Show me. 64, 80. Oh, come on. Okay, well, that looks fine. Oh, it doesn't include the beginning. That's... It shouldn't really matter. I mean, obviously it would be wrong, but it shouldn't be causing this error. For px, py, and path. Path out of pand, par, well, path minus 1 is not none. Oh. That one we do need to do because we have the none. Okay, we get more colors yet again. And show me the path. Oh, I just noticed this. So tiny. Ooh, look at that. And this doesn't tell you anything about, like, it's a little hard to read, but I think it just basically went up here and then this is blocked off. So it went over here, then to the right, then it went down, and then it went down, and then it didn't go here. So that means it went left at this intersection. Yeah, one thing I thought of was I could add like a gradient to this path. Maybe I should just do that. In fact, it shouldn't be too hard. So, what's the actual length of best path? 35. And 200. It's not the 200. It's the 150 over 35 is 4-ish. So, let's do 200 minus 4 times j, and then slap on this, and now we'll get a nice gradient. And the best part is I can just rerun this. Oops. Oh, that's nice. Well, it's not actually that like aesthetically nice, but it's nice in that you can actually tell now where it's going. It's a little hard to tell that these aren't connected because the gradient is like kind of subtle. I guess I could do like 230 minus 5. Maybe that'd be a little better. I don't know. I said 35, right? I mean, I could even do more. So yeah, if I make it like really extreme. But it should get pretty dark now. Yeah, there we go. Cool. That's neat. Yeah, it's kind of interesting. It's not that interesting, but this little segment here doesn't get used. There's like no way you could use it, but probably that gave some of the shorter paths when DFSing. Like some of the shorter paths probably look exactly like this, except you take this little shortcut here. Neat. Okay, well, I can't come up with anything else that interesting to do visualization-wise other than maybe like make some videos. I might do those later, but those are like kind of more of a pain to do, so. Cool, yeah, that is all I have for real this time for Advent of Code day 23. And I guess I'll check what happened to my leaderboard position. I'm up to 7. Oh, that is exciting. Oh no, but I'm gonna choke it now. I already know. I did get 16 and 15, which is like a pretty solid finish. And I guess yesterday, the 4 and the 2 probably meant that even though I was 10th yesterday, I think I was like close to the people ahead of me. So nice. Well, yeah, I will see you tomorrow.